In this lesson, we're going to sketch a polynomial function. We've learned quite a bit about polynomial functions, so in this lesson we're sort of going to put it all together and look at what that does to its graph. So here is sort of my checklist of what the steps that I will go through to graph. I'm going to start by using the leading coefficient and degree to determine the end behavior. So that's when I'm looking at the basic overall shape of the graph. If it's linear, it's going to look like this. If it's quadratic, if it's cubic, if it's quartic, if it's quintic, etc. I'm looking at the end behavior, whether it starts up or down, whether it ends up or down, and the overall shape of the graph using that leading coefficient, positive or negative, and the degree. So this is a degree of 1, 2, 3, 4, 5, etc., etc., etc. Then I'm going to find my y-intercept by evaluating f of 0, which means I'm going to plug in 0, find the y-intercept. I'm going to determine if it has x-intercepts and their multiplicities, and then plot those x-intercepts. I'm going to say if the function is even or odd. Then if it is, I can plot some symmetric points. So remember that's saying if it's even, then f of x is equal to f of negative x. If it's odd, then f of negative x is equal to negative f of x, which means it's symmetric to the origin. Over here it's symmetric to the y-axis. If I need more points, I'm going to basically plug in values. I'm particularly going to do that for turning points. So if it's between two x values, I'll probably plot some point in between to see how low the graph will go, etc. And then of course I'm just going to connect my points from left to right, paying close attention to the multiplicity of the x-intercepts and what that does to them. So let's do this one together. Again, I'm going to start with the degree, which is 1, 2, 3, 4. So this is a degree of 4, which means the overall shape is going to look something like a W. The leading coefficient is positive, and so therefore I know it's going to go up from left to right. So now I'm going to find some points that are on my graph. So I'm going to start by doing f of 0, which is 0 minus 1 squared, 0 plus 3, 0 minus 4. That gives me 1 times 3 times negative 4, which gives me negative 12. So the y-intercept is negative 12, which is somewhere in here. That's my first point. I'm then going to say 0 equals all of this. And again, these are nice. I am not going to FOIL all of this out because that would be insane. It would take a lot of work and it wouldn't do me any good. So if I set x minus 1 equal to 0, I would get x equals positive 1. That of course has a multiplicity of 2, which means it's going to turn. It's going to touch and turn at 1, which is here. X plus 3 equals 0 gives me x equals negative 3. It's going to go through at negative 3. And then of course x minus 4 equals 0 gives me x is 4, and it's going to go through at x is 4. So what I know so far is it's going to look something like this. It's going to come up to 1, it's going to turn and come back down, and then it's going to come back up again. So that's what I know so far. It's not going to be even or odd in this case at all. So now I just need to find a couple of other points. So other points that I might find is some point particularly between 1 and 3. So let's find f of 2, which means I'm just going to find at what value I would get when f is 2. So 2 minus 1 squared, 2 plus 3, 2 minus 4, gives me 1 squared, which is 1, times 5 times negative 2, which is negative 10. So at 2, we're at negative 10. If you wanted, you could even plug in 3. So plugging in 3 would give me a little more idea as to what's happening between these 2 points. I'm going to go ahead and find, say, f of negative 2 to get a better idea of what's happening between these 2 points. So I know it goes through here. I want to know what's going on about right here. So if I plug in -2, I find -54, which is somewhere in here. So that does give me a better idea of what's going on. Now, I can choose to stop here. If I wanted to be more exact, I would probably find f of -1 and also f of 3, but I don't need to be completely exact. So I'm just going to sort of wing it from here. So my graph's going to look something like this. Now, did I do an awesome job? No, because I should have probably found another point in here and another point in here so I could see exactly what the sketch of my graph looks like. Now, if you're interested, take this function and plug it into Desmos and see what the actual graph looks like. As you can see, I have now plotted this function in Desmos. I didn't do any work to FOIL it out. I suggest not doing that because there's far too many ways to make a mistake. But now I can see what my actual function would look like, and I can even sort of use my slider down here to determine what my lowest points are. So here would be my lowest points. Obviously here are the points that I've plotted to begin with. So all of those points are what I plotted, and then these would be those other points. You can find any point along the graph just by sliding your cursor. So I'm just pressing the button as I'm sliding my cursor. So I know that I also found at -2, which was about -50 whatever. Again, you can do that for any of the points on the graph, but this gives you the actual graph as opposed to our rough sketch that we did ourselves. Here's one for you to try on your own, so press pause, go ahead and graph the rough sketch of the graph, and then press play to check your work. So again, I would start by looking at the degree, which is 1, 2, 3, so x cubed. Normally would look like this, but this negative in front tells me that in fact it's going to start up and end down. So that's very important. I'm also going to obviously find some actual points to plot on my graph. So I'll start with f of 0, which is -0 plus 1, 0 minus 3, quantity squared. So that gives me a negative, and then 1, and then 9, so -9. So at 0, I'm at -9, which is about right here. That's my y-intercept. My x-intercept I find by setting x plus 1 equal to 0, which gives me x is -1 with a multiplicity of 1. And then setting x minus 3 equal to 0 gives me x equals +3, but that has a multiplicity of 2. So at 3, I know that my graph is going to turn around and come back down. So it's looking like it's going to start up here, go through this point, somewhere down here, it's going to turn around, and then it's going to come back down. Now, in order to get a better idea, I would first look if it's even or odd. It doesn't appear to be either of those things, so it's not going to be symmetric in any way. So now I'm just going to plug in some points to get a better feel for the graph. I don't really care what's happening up here because I know it's just going to go off to positive infinity. But I do want to have an idea of what's going to happen between this point and this point. So I might plug in f of 1 and find the value there. So -1 plus 1, and then 1 minus 3 quantity squared, which gives me negative, and then 2, and then 1 minus 3 is -2 squared gives me 4. So at 1, I get -8, which didn't help me too much. But now I'm probably going to go ahead and plug in f of 2 because I want to know what's happening here. F of 2 would be -2 plus 1, and then 2 minus 3 quantity squared. So I have a negative out front, and then 3, 2 minus 3 is -1, squared makes it +1. So that's -3, which is about right here. So now I have a better idea, and then I might, just for fun, plug in f of 5 so that I can see exactly how far down I'm going to be there. -5 plus 1, and then 5 minus 3 squared, which gives me -6 times 4, that's -24. So that's even off of my graph. So I know over here it's going to be very far down. So when I'm graphing, I know again here this is a turning point, so I'm starting up high. I know it's going to come up here and then it's going to end up coming back down very far. So something like that. Again, you can use Desmos or a graphing calculator to go ahead and graph that and check to see what the real graph looks like.